Welcome to video 6, scatter plots. Statistical studies are done where data is collected on two variables to establish whether there is a relationship between the two variables. This is called a bivariate data analysis. Data is represented in a scatter plot. Data points, x, y, are plotted on a grid that represent the specific variables. And then scatter plots are analyzed to determine if there is a relationship between these variables. So when we look to determine if there is a correlation, we are always looking for the pattern that is visible in a scatter plot. So for example, if we look at this first one, we can see that generally they're going from a low point, their low x and y value, to a high x and y value. As the x values increase, the y values also increase. Or as the y values decrease, the x values decrease. This is a positive correlation. The next one shows that as x values increase, y values decrease. So as we're going from here, the x value is low, the y value is high, and then it continues to go, x increases but y goes down, or vice versa. This is called a negative correlation. And then we'll have scatter plots where there's really not any visual pattern. There's like a high and low and they're all over the place. That'll show no correlation, meaning really there isn't a positive or negative relationship there. When analyzing the data, we're looking for the correlation coefficient, and that's the R number. This describes the strength of the relationship between the equation found and the data points. So when we have a positive correlation, the R value will be greater than 0 but less than or equal to 1, and the closer to 1, the stronger the correlation. A negative correlation means the R value is greater than or equal to -1 but less than 0. And the closer to -1, the stronger the correlation. And that's a little bit difficult for people to get right away because the negative seems like it's a small number, but really it's just showing that the correlation is negative. But being close to a -1 is just as strong as being close to +1. The next thing that we'll look at is causation. This is a cause and effect relationship. Two variables can have a strong relationship with one another on a scatter plot, but might not have a causal relationship. A causal relationship exists when the change in one variable actually causes the change in the other. Again, that's called a causal relationship. Exercise 1 says, in each of the following scenarios, two variables are given that, if plotted, would have a strong correlation. We want to determine if there exists a causal relationship between the two variables, and if so, which variable causes the other. So the high temperatures in New York City and the number of bottled waters sold. While higher temperature might have a correlation with the bottles of water going up, this is not actually causal. I said no because the high temperatures does not cause water to be sold. Again, higher temperatures might cause someone to have more thirst, which does in fact increase the number of water bottles sold. It's not causal. B says that a person's weight loss and the number of hours a person spends in the gym per week. I think this one is causal because the hours at the gym do cause the weight loss. So as you're working out, that's causing you to sweat and lose weight. So that does cause the weight to go down. Now we're going to jump down to recalling the functions that we studied this year. We learned linear function showing a positive where it goes upward or negative going downward, exponential as a positive exponential or a negative exponential, and quadratic with a smiley face parabola and a frowny face parabola. Using these functions, we're going to try the bottom part here. Identify what type of function is being modeled by the scatter plot below. This one looks like it would be a linear negative relationship. I can see that because as the x values increase, y values decrease, or vice versa. Next one, it looks to me like this is going to be going generally, they go in a curve pattern like an exponential function. So this is, I'm going to say, an exponential decay. And the last one seems to look like a smiley face parabola, so I'm going to say a quadratic positive. Okay, that's it for this video. I'll see you tomorrow. Have a good night.